So, a friend asked me a couple years ago if we brought a caveman to the current times, what would be the hardest thing for me to explain to this caveman? And that gave me pause because a lot has changed since then. If you went out onto the street and asked just a normal everyday person whether or not they knew about certain aspects of the universe, they would give you an answer that would have astonished people up until now that we didn't know until recently. And the average person today knows more than humanity has in the past. And so it would be hard to reason with this Neolithic caveman. But it made me think about, well, how would a caveman reason? And so I did some research. I studied and I saw that Encyclopedia Britannica says that about 42,000 years ago, there was a Neolithic man group called the Cro-Magnon Man. And this group was very special. They were using tools, they were using shelter, and they were able to solve basic puzzles from what we can understand about them. And so most of their reasoning would be through trial and error, even though they don't know the ways behind what they're doing. They did have a way to figure out what they were doing. And unknowingly, that kind of seeded the base for science. And it took a long time to develop, but eventually you see, thousands of years later, places like the Baghdad House of Learning and these ancient Greeks that were all concerned with how can we know stuff, how can we build our knowledge to expand what we can do and understand the universe better. And in this early area, we see that Archimedes found ways to measure volume and density, and we see in the Baghdad House of Learning there are early signs of learning optics, and all of these would be expanded upon. But it wouldn't be until about the 1500s, until Galileo Galilei came along, that we would actually have a solid base for examining claims and making evaluations based on those claims. And he came up with a scientific method, which basically means that we can now hypothesize and come to conclusions and either disprove a hypothesis or prove that the hypothesis has the best chance of being correct through this method, through the scientific method and through peer review. And this was a big step, though initially it wasn't well built upon. But eventually, a man named Isaac Newton came along, and he used the scientific method to prove that gravity existed and to prove how forces worked. And he came up with a theory of motion. And he revolutionized the way that we saw what was going on in our world. And people came along like Michael Faraday and Nikola Tesla and Schrodinger that all built upon this. And some of these are really well known for what they've done. Michael Faraday, according to the BBC History Channel, in the early 1800s and the late 1700s was working on science, and he developed capacitors that help modern day computers work. We still use this right now, even though it was a couple of hundred years ago. And most people understand electromagnetism, but that was something groundbreaking for them back then. And so you see Nikola Tesla, he developed the RC system, the radio control. He developed AC power. He was a very big futurist. He was looking towards what he could do, and he was looking towards what he could try to build to help further humanity. And Schrodinger even came up with certain theories that helped develop quantum mechanics, and he helped invent thermodynamics. And this all culminates to our knowledge now. We know more about the universe from these things that have happened, and we can do more with these things than many of these inventors and mathematicians and scientists could have ever hoped or dreamed of ever creating. And so our knowledge, as Isaac Newton once said, is based on the back of giants. We stand on the back of these giants, like Isaac Newton, like Schrodinger, like Tesla, and we develop more and more, and we understand more and more about our universe, about how things work. And so today we kind of have this massive knowledge that for the past we haven't had. And so if I went out and asked, what are the 3 parts of an atom? And someone gave me the answer, protons, electrons, and neutrons. Well, we didn't know that all 3 of those were a part of the atom until the 1900s. And so we have basic things like electromagnetism and the way that X-rays work and just tons of scientific information at our fingertips, and we take it for granted sometimes, but it's so much that we can work on. You can see physics in buildings and cars. Physics has allowed us to make marvels of engineering like the Burj Khalifa, and it allows us to use cars for transportation, trains, planes, anything. It's opened up the world to be much bigger than it used to be. Thanks to technology, we have so much more interconnectivity between humans, and we can explore so much more of our universe that we really have gotten to this point where if a caveman were to come to today, I don't know what I would have a problem explaining. But based on our history, I do know where I could start. And I could start with physics. I could start with explaining how we can know things, and explaining what we do know and what we know to be true, and showing them how we know what we know and why it works. And eventually, I can explain most of what we know. That being said, this is only inspired by scientific creativity and scientific curiosity. And it is only by questioning why or how or what can we do with this that makes it where we can explore and discover and create. And so maybe you're not interested in science the way Isaac Newton was, or maybe you're not a mathematician, but there are things you can do and create now that can revolutionize the world. And it's important that we support that scientific curiosity, and we support that artistic curiosity, and we support others in their endeavors. And so, with that, I would like to thank you for allowing me to kind of give this talk and take you along this journey with me.